Assalamu alaikum friends. I am Taqdees Siddiqui with Computer Graphics, a course for Bachelor's in Computer Science being offered by a virtual university, Government of Pakistan. Today is our 32nd lecture. We have talked about some lighting and shading for quite a few lectures now, and as I promised last time that we are going to start walking towards implementation specific details. So today we'll start our discussion about OpenGL. So let's begin. OpenGL, the Open Graphics Library, so talked of, how it initiated and when and what are salient features about it, we'll try to cover those today. This is the most widely adopted graphics standard since its inception way back in 1992. Almost a decade and a couple of years more have gone by, and during this time, more and more graphics programmers have come up with innovative ideas making use of the same library. This is a multi-platform library. Rendering, texture mapping, special effects, and other powerful visualization functions are natively available in this library. Being multi-platform and being open source, it is choice of most of the programmers today that want to do two-dimensional or three-dimensional high resolution, high performance graphics. Whether the application is a requirement of a simulation program or the output is the requirement of a game, OpenGL library helps graphics programmers a lot. High quality, high performance. Very high quality images can be created using OpenGL functions which are pre-built for us. It is available as an application programming interface, an API, and we can trust pretty high performance generated by the functions which have been coded in there. Performance is a big issue when it comes to rendering three-dimensional objects, or even when we are talking about some 2D simulations as well, depending upon the amount of details that need to be covered. And OpenGL provides us with pretty high quality and high performance graphics. The markets in which there are applications of OpenGL is in broadcasting, computer-aided design, computer-aided manufacture, and computer-aided engineering. In the field of entertainment, a lot of applications. OpenGL is choice of entertainers, the developers for the entertainment industry. Medical imaging, and also in virtual reality. OpenGL has got many applications. These are only a few to mention, but the sky is the limit when you talk about possibilities with OpenGL. When it comes to graphics, when it comes to making things that can be drawn to display to make effect, OpenGL is there to help. We have so many things to do, we have so much more to learn, and so much fun to generate using the OpenGL. There are certain advantages that can be had because of the use of OpenGL, specifically from the perspective of developers. So the things that are going to interest developers or developers love about OpenGL, they are quite a few. We'll try to cover a few of them. The first and foremost is that it is industry standard. OpenGL Architecture Review Board, ARB, is a standardized kind of a body which is always scrutinizing any input coming back from the developers, making use of that feedback and input to come up with new extensions to OpenGL as well. But this whole thing is pretty controlled, pretty standardized. But nevertheless, as per requirements of the current industry, OpenGL continues to evolve, and this is the good part. There is a broad industry support. OpenGL applications, as we have just seen, the areas in which we have applications of OpenGL are really diversified. So if you master OpenGL programming, you actually can be absorbed in multiple different industries. When we talk about support from the hardware industry, this being an open standard is actually supported by almost all the accelerated graphic adapter cards and the allied hardware. The only truly open, vendor-neutral, multi-platform graphics standard also makes OpenGL to be a very native choice for the developers. It is the only truly open, as they call it, because any and every platform supports OpenGL. Open graphics library would be available for Linux, would be available for Windows, 32-bit versions of Windows, they support OpenGL. Then the stability of the library, that is also another important salient feature which makes it a native choice for the developers. It is available for more than a decade. Definitely it sounds stable, that is why it is around for such a long time. On a wide variety of platforms, no matter what is your choice of developing your animations or your displays or 3D objects in, OpenGL is available. You can make use of the functions and the features available in here. It would be available on multiple different platforms. It is well controlled in terms of additions to the specifications. As I said earlier, that OpenGL Architecture Review Board, or ARB, is a body which controls all these specification changes that require to be made to the OpenGL specifications. So having a body which formally reviews any and every change that needs to be brought about, that makes it pretty trustworthy as a controlled addition and change of specification environment. Proposed updates in the OpenGL are announced in time, and that helps programmers to adapt to those new changes quite easily, well in time, even for anything that they are planning to develop and they are just started working on it, they can make use of those new changes which are announced in time. And then, of course, last but not the least in this is backward compatibility. Whenever we talk about backward compatibility, well, what we mean is that anything that has been developed using a specific standard previously, that should still hold good. अगर हमने नया कोई प्रोग्राम लिखा जो नए स्टैंडर्ड के मुताबिक है, of course that would be current one, लेकिन उसी नए स्टैंडर्ड्स के मुताबिक बनी हुई लाइब्रेरी को यूज करते हुए अगर पुराना बनाया हुआ प्रोग्राम भी चलाया जाए तो वो भी इफेक्टिवली चल सके. That's what the backward compatibility would mean. So any and every new version that we come up with, or new extensions that we come up with for OpenGL, those would be supporting the existing ones. So जो पहले वाले प्रोग्राम बने हुए हैं वो अभी भी नए वर्जन्स के साथ भी इफेक्टिवली इस्तेमाल हो सकेंगे, चल सकेंगे. So डेवलपर्स का किया हुआ काम जो उन्होंने पहले से डेवलपमेंट कर रखी है वो मतलब थॉरोली रिवैम्प करने की जरूरत नहीं पड़ती. अगर उसको एज इट इज वो हमारी रिक्वायरमेंट्स पूरी कर रहा है, वट एवर पर्पज इट वॉज रिक्वायर्ड टू सर्व, अगर वो सर्व कर रहा है तो वी कैन मेक यूज ऑफ द न्यू वर्जन ऑफ द लाइब्रेरी एंड रन द ओल्ड वन प्रोग्राम्स एंड रन देम as effectively as they were run originally when they were made in the previous version. Then the reliability and portability of this OpenGL library is another attractive feature for the developers. Consistent visual display results on any OpenGL API compliant hardware regardless of operating system or windowing system is definitely an advantage. आपने एक मर्तबा अगर एक एनिमेशन प्रिपेयर कर ली है, no matter for which platform you made it, अगर आप उसको किसी दूसरे प्लेटफॉर्म पे ले जाना चाहते हैं, इट्स पेनलेस प्रोसेस. सो effectively an exercise that has been done for Windows will not require any rework to be run on Linux platform. So अगर हमारे पास कोई एक स्पेसिफिक एप्लीकेशन यूजिंग OpenGL किसी भी एक प्लेटफॉर्म के लिए बनी पड़ी है तो उसको किसी भी दूसरे प्लेटफॉर्म पर इस्तेमाल किया जा सकता है विदाउट हैविंग टू चेंज द कोड. जितने भी नेटिव हार्डवेयर हैं उनके फीचर्स जिनको इस्तेमाल करती है OpenGL एक्सेलरेट करने के लिए ग्राफिक्स को, उनके लिए इंटरफेस वो स्टैंडर्डाइज्ड ही है. सो रिगार्डलेस ऑफ a change of hardware at the bottom, we will be able to still run our OpenGL programs very well. Then the concept of evolution, which is very much there. ऐसा नहीं हुआ कि OpenGL एक दफ़ा बना दी गई, उसके contents जो हैं वो तय हो गए कि this is going to be the interface and this is going to be what it is going to cover, और उसके बाद फिर people started using it. It is evolving. इसके अंदर changes आ रही हैं, new things are being added. So बहुत सारी जो एवोल्यूशन है वो अभी भी हो रही है. न्यू रिक्वायरमेंट्स, new hardware features which were not originally or natively supported previously. They are now being supported by hardware and can be exploited by OpenGL. OpenGL is open to such evolution and such changes. So that is what allows some new hardware innovations to be accessible through the API, to the same API. OpenGL extensions mechanism is another controlled environment, as we have talked about, brought about by ARB. The Architecture Review Board takes care of it, that appropriate extensions as and when required are floated for OpenGL. Then scalability. OpenGL API-based applications can run on consumer electronics, on personal computers, workstations, or even on supercomputers. So applications are truly scalable. Regardless of it, that it was originally designed to be run on a PC, it would still be effectively runnable on supercomputers. So a duplication of effort would not be required. As a result, applications can scale to any class of machine that the developer chooses to target, regardless of it कि originally बनाई किसके लिए गई थी. बनाई गई थी किसी consumer electronics के लिए, can still be run on a PC. बनाई गई थी workstations पे run होने के लिए, can be run on supercomputers. Was made for supercomputers? Well, of course, can be run on other computers as well with certain implications of efficiency. Easy to use. It's very well structured. Design is pretty intuitive. Commands are logical. And the routines are efficient. Efficiency is a great concern when it comes to real-time graphics programming. We have talked about the requirements of the games programmers. So they love it because of its efficiency. Compact programs and code. Hardware features independent coding is possible. Well documented. There are many third-party books and a lot of sample code available. As I said earlier, there are so many resources available. So much has been written about OpenGL that we can make use of many third-party textbooks. We can make use of quite a lot of sample code which is available around the globe and can help us start our walk with OpenGL. This journey would be accompanied by a lot of material which is already there. We can make use of all that and we'll be able to come up with very compact programs because of the fact that the OpenGL library has been written making use of the most efficient routines available. The routines that we have been talking about in our discussion behind the scenes theory of computer graphics, many of those routines that apparently would be very, very difficult to implement if we are doing that natively in C or C++, they are pre-built and available for use in our programs in OpenGL. And that is what makes this OpenGL our natural choice whenever it comes to development of high quality, high performance computer graphics. As a software interface for graphics hardware, OpenGL renders multi-dimensional objects into a frame buffer. Basic idea, 2-dimensional और 3-dimensional objects render करने का. OpenGL काम इस तरह से करता है कि जितने भी objects हम इसमें draw करना चाहते हैं, 2-dimensional और 3-dimensional objects, उन्हें ये एक frame buffer के अंदर, multiple dimensions वाले objects को एक frame buffer के अंदर render करता है. Makes them available over there for use by the native hardware in order to portray the picture which has been made making use of the available functions and library, the OpenGL library. OpenGL is an industry standard graphics software with which programmers can create high quality still and animated 3-dimensional color images. We have talked about this before, that this is the choice of the programmers which are interested in making high quality graphics. No matter the requirement is that of stills or that of animation, we are going to have moving objects or we want to have only life put into objects that are still in a specific scene. Whatever the requirement may be, OpenGL helps us find the answer. Application of OpenGL. OpenGL is built for compatibility across hardware and operating systems. This architecture makes it easy to port OpenGL programs from one system to another. So we have made programs for a specific hardware, fine, can run on other. We have made it for a specific platform, specific operating system. We want to take it to another operating system. The process is pretty painless. We can do that very easily. Currently, the way we are going to approach our specific developer audience would be the C and C++ programmers only, although extensions of OpenGL are also available for various other languages, which include Ada as well. We also have it for Fortran. Runtime requirements for OpenGL: it can run on Linux and it can run on all the 32-bit versions of Microsoft Windows, as you just said. We have OpenGL library available for all versions of the Windows, 32-bit versions, and it is also natively available for execution on Linux. The main purpose of OpenGL, as we've already discussed, it is to render 2- and 3-dimensional objects into a frame buffer. These objects are described as sequences of vertices that define geometric objects or pixels that define images. We are talking about the 3D and the 2D objects which would be rendered into the frame buffer. What are these objects? These can be collection of vertices, because we have been playing with them for quite some time now. The idea is native to us that we can make use of vertices to make different objects, different figures, different polygons. हमने surfaces को divide किया है tessellation के अंदर into multiple triangles, और triangles का data जो है वो हमने देखा कि उनको हम vertices की मदद से identify करते हैं, और for that matter any polygon that would be defined making use of vertices. So या तो हमारे पास वो vertices होंगी जिनकी मदद से हम geometric objects बना सकते हैं, या फिर we'll be dealing with pixels which would form the images. For instance, एक human figure, a picture of a child, and that would be a pure pixels defining image. And if we are talking about a circle, maybe a cone, a triangle, a pentagon, we'll be talking about such geometric objects that can be defined making use of vertices. So one of the two would be involved whenever we are talking about graphics at a specific instance in time. For any particular requirement, of course, both of them would be joining hands together to give life to our pictures, to our images, to our views. OpenGL performs several processes on this data to convert it to pixels to form the final desired image in the frame buffer. There are a number of processes that OpenGL carries out on the input data. If you're talking about those vertices that are going to become the basis for making geometric objects, or we are talking about the pixels, the very pixels that define the image that we want to make use of, no matter what, OpenGL processes them in multiple stages or multiple phases. And those phases together form a pipeline, a processing pipeline that we are going to take a look at shortly. How OpenGL works. We are going to have a view, a global view of how OpenGL works. We are talking about primitives and commands, OpenGL graphic control, execution model, and some basic OpenGL operation. We'll take a look at each of these one by one, that what they mean and what they cover and what they are talking about, what they are addressing. We'll be starting, of course, with the first one, the primitives and commands. What primitives are supported by OpenGL for drawing, and what are the commands that are available that we can execute for those primitives. The OpenGL draws primitives including points, line segments, and polygons. So we can make use of the natively available functions in this API to draw any and every primitive that we have listed thus far. We can draw put points, put pixels, we can draw line segments, and we can join line segments together to form polygons. Effectively, those polygons get defined making use of the vertices, and once we've got the data about those vertices available, we can always make use of that data to come up with polygons. OpenGL would provide us functions for each of these primitive drawings. OpenGL draws these primitives subject to several selectable modes. We have talked about graphics modes. We can select any one of multiple available modes in order to start drawing our primitives. And user can control modes independent of one another. So we can have changing of or switching of modes from one to another, and depending upon what mode we have selected, we can come up with different type or different looking output using the same functions. Primitives are defined by a group of one or more vertices. A vertex defines a point or an endpoint of a line or a corner of a polygon where two edges meet. We have been talking about vertices. The primitives that we are talking about, they are the point, the line segment, or the polygons, and they all can be defined making use of the concept of a vertex. A vertex alone would suffice the requirements of a point. A couple of vertices would suffice the requirements of endpoints of a line segment. आपको एक line draw करनी है. All you require is the first and the second point, the starting and the ending point. So a vertex suffices the requirement. हमारे पास दो अगर vertices की values मौजूद हैं, we can treat them as the starting point and the ending point of a line segment and draw line between the two. Similarly, अगर हमारे पास multiple vertices की definition मौजूद है, they can all be used to draw polygons. If you've got three of them, what shall we be drawing? Of course, it would be a triangle and four cornered figures or five cornered figures, and we can have many possibilities when we start adding to number of vertices. The things that we have seen would still be holding in terms of basic theoretical concepts that we have been building. Those would actually come handy when we'll get to know what is pre-built in OpenGL and what can be made use of without a lot of effort. We'll be discovering all those hidden features of OpenGL in the coming days, inshallah. Following data is associated with a vertex: its coordinates, its color, normal, texture coordinates, and flags. Whenever we talk about a vertex, there are certain things that have to be there. Primitively, of course, coordinates तो उसके होना ही पड़ेंगे जो ये बताएं कि वो है कहाँ, लोकेशन क्या है उसकी. x y coordinates की जिस तरह हम बात करते हैं 2 dimension में, 3D के अंदर x y z coordinates की बात करते हैं. So the vertices information has to include the coordinates. तो coordinates की information मौजूद होगी. फिर ये होगा कि उसका कलर क्या है. Color is also important whenever we are talking about, well, primarily drawing objects and then later on filling them as well. आपको याद होगा जब हमने बात की थी कि हम मुख्तलिफ तरह के शेडिंग के तरीके हैं जिनको इस्तेमाल कर सकते हैं. यू वुड रिकॉल प्लेन शेडिंग के अंदर तो हमने किया था कि फ्लैट शेडिंग के अंदर हमने सिर्फ एक ही कलर के साथ अपने ऑब्जेक्ट्स को टिपिकली ट्राइंगल्स को फिल कर दिया था. लेकिन जब हमने गोराव शेडिंग की बात की तो वर्टिसेस के ऊपर जो कलर्स हैं वो बड़े इंपॉर्टेंट थे हमारे लिए इन ऑर्डर टू बी एबल टू इंटरपोलेट all the colors between the two endpoints. So the color information would be part of our vertex data. Vertex data would also include the information of a normal on that vertex. आपको याद होगा कि जब हमने बात की मुख्तलिफ तरह से लाइटिंग और शेडिंग के हवाले से, तो हमें किसी जगह पर सरफेस के ऊपर नॉर्मल और किसी जगह पर वर्टेक्स के ऊपर नॉर्मल को लेकर के अपनी प्रोसेसिंग को आसान करने में मदद मिली. सो नॉर्मल ऑन अ वर्टेक्स is another important part of the vertex data or data associated with a vertex. Texture coordinates और flags. जब हमने texture mapping की बात की थी तो उस वक्त हमने ये जिक्र किया था कि whatever object we want to fill making use of a specific texture, उसके अंदर हमें टेक्सचर के वो कोऑर्डिनेट्स जिन्होंने मैप होना है ऑन टू स्पेसिफिक कोऑर्डिनेट्स ऑफ आर ऑब्जेक्ट और सरफेस ऑफ ऑब्जेक्ट, उनको आपस में रिलेट करना जरूरी होता है. सो किसी एक स्पेसिफिक वर्टेक्स जो कि हमारे ऑब्जेक्ट की सरफेस पे डिफाइंड है, उस पर हमारे टेक्सचर का कौन सा वाला हिस्सा मैप होना है, उस हिस्से के कोऑर्डिनेट्स, वो भी एक इंपॉर्टेंट इंफॉर्मेशन है जो कि हमारे वर्टेक्स के साथ रिलेटेड है. एंड दीज ऑल वुड बी मेड यूज ऑफ व्हेन वी मेक यूज ऑफ routines from OpenGL. Each vertex and its data is processed independently and is processed in the same way. अगर हमारे पास मल्टीपल वर्टिसेस हैं जिनके साथ रिलेटेड डेटा हमारे पास मौजूद है, जैसा सभी हमने बात की कि उसका कोऑर्डिनेट्स हैं, कलर है, नॉर्मल है, अगर टेक्सचर मैपिंग यूज कर रहे हैं तो एसोसिएटेड टेक्सचर मैप के कोऑर्डिनेट्स हैं, ये तमाम चीजें अगर हमारे पास मौजूद हैं एंड वी आर प्रोसेसिंग मल्टीपल वर्टिसेस, तो हर एक वर्टेक्स का डेटा जो है वो इंडिपेंडेंटली प्रोसेस होता है, अलग से होता है, लेकिन जितने भी वर्टिसेस होंगे उन सब के लिए एक ही प्रोसेसिंग का मैकेनिज्म या तरीका इस्तेमाल होगा. द वे द फर्स्ट वन इज प्रोसेस्ड, द वेरी वे द सेकंड एंड थर्ड एंड सो ऑन, ऑल अदर वर्टिसेस वुड आल्सो बी प्रोसेस्ड. जहां की हमारी रिक्वायरमेंट होगी, जिस तरह से अभी हम बात कर रहे थे गोराव शेडिंग की, वहां पर ऑफ कोर्स two vertices are required in order to come up with the values in between for all the colors. Well, of course, those would be made use of. But the routines that exploit that data would treat each of these vertices as if they were the same. The same essentially, not in terms of all their attributes and the data, but of course, in nature, they are vertices and vertices are treated the same way. Exceptions are cases in which the group of vertices must be clipped so that a particular primitive fits in a specified region. And in this case, vertex data may be modified and new vertices created. We have talked about these issues when we are talking about clipping. अगर हमारे पास जो displayable area है, उसके अंदर कोई primitive जो है वो completely पूरा नहीं आ रहा है, so depending upon what type of clipping we want to use, we will have to modify our vertex data. वर्टिसेस जो ओरिजिनली मौजूद हैं उनकी मदद से अगर हम ऑब्जेक्ट क्रिएट करते हैं तो वो इस तरह से फ्रेम होता है, बनता है कि हमारे व्यू पोर्ट के अंदर वो पूरी तरह से दिखाई नहीं दे रहा, एंड वी वांट टू क्लिप द एक्स्ट्रा पार्ट्स दैट आर फॉलिंग आउटसाइड द रीजन, डिस्प्लेएबल रीजन. सो वील हैव टू कम अप विद सम न्यू वर्टिसेस मे बी. जैसे हमने बात की थी कि अगर हमारे क्लिप रेक्टेंगल के अंदर एक ट्राइंगल का टॉप जो है वो नहीं आ रहा, तो ऑफ कोर्स व्हाट वुड अपीयर would be a four-cornered figure within our scope of vision, within our displayable area, within our clip window or clip rectangle. So उस सूरत में ओरिजिनली जो 3 वर्टिसेस से फिगर बनी हुई थी उसके वर्टिसेस फिर मॉडिफाई होकर 4 हो जाएंगे. इट इज क्वाइट पॉसिबल फॉर मेनी डिफरेंट ऑब्जेक्ट्स whenever we are talking about these exceptions handling, the vertices that fall outside our clipping area. The commands. Commands are always processed in order, though there may be an indeterminate delay before a command takes effect. We have talked about the primitives, we are talking about the commands. As I said, that the commands are always processed in order. The very order in which they are issued, in which they are offered for execution, that very order is followed for their execution. But there can be a delay in processing of a specific command or the other, or a number of commands. The reasons we'll be able to appreciate in a short while, but for the moment you can just suffice this would suffice saying that there are certain things which take some time, and while they are happening, all other commands, they are queued, they wait for their turn before they get executed. So it's not necessary that as soon as a command is issued, it gets carried out. There can be some delay before the command actually takes effect, or its effect is evident or visible on our display device. Each primitive is completed before next command. Therefore, state querying commands return inconsistent data. As I said, ये वाली चीज़ समझने के लिए हमें थोड़ा सा इंतज़ार करना पड़ेगा, थोड़ा आगे जाकर के हमें ये बात समझ में आ जाएगी और वाज़ेह हो जाएगी कि इसके पीछे रीज़न क्या है जब हम इसकी इम्प्लीमेंटेशन स्पेसिफिक बातें कुछ और देखना शुरू करेंगे. लेकिन फॉर द मोमेंट आप ये जान लीजिए कि हर एक प्रिमिटिव जिसको हम ड्रॉ करने जा रहे हैं वो पहले कंप्लीट होता है और उसके बाद फिर अगली कमांड की बारी आती है. तो जब तक एक प्रिमिटिव कंप्लीट नहीं होगा उस वक्त तक नेक्स्ट कमांड की एग्जीक्यूशन शुरू नहीं होगी. तो एट टाइम्स वी हैव multiple different windows in which we are doing multiple different things. और उसके लिए जो सर्वर हमारा यूजर है वो तो एक ही है. So ऐसी सूरत में we may have certain scenarios in which a specific command issued for a specific scene in a specific window that may be delayed by some time before it gets executed. And then there are certain commands जो help करती हैं कि हमें current state ऑफ विंडो और कॉन्टेक्स्ट वो बताती हैं या रिटर्न करती हैं. सो वो एट टाइम्स दुरुस्त नहीं होती. उसकी वजह ये होती है कि देर कैन बी सर्टन कमांड्स विच आर वेटिंग फॉर एग्जीक्यूशन इन दैट कॉन्टेक्स्ट एंड द करंट स्टेट इज द प्रीवियस वन. OpenGL graphic control, that's what we are going to discuss next. OpenGL provides you with fairly direct control over the fundamental operations of 2 and 3 dimensional graphics. We'll be seeing how we can control the making and the display and the maneuvering of 2-dimensional and 3-dimensional objects which are displayable in our specific display windows. This includes specification of such parameters as transformation matrices, lighting equation coefficients, anti-aliasing methods, and pixel update operators. These things can be specified and can help us have a better, stronger, more stringent control over our objects, no matter whether they are 2-dimensional or 3-dimensional objects. Making use of these parameters, we can control their behavior. Transformation matrices, we have talked about them when we were talking about 2D transformations and then later on 3-dimensional transformations. So knowing the basics, the basic concept lying behind the transformation matrices and composite transformation matrices, we can change values for these transformation matrices, supply them as parameters affecting the current state of our objects. For instance, अगर हमने किसी ऑब्जेक्ट को ट्रांसलेट करना है तो उसके लिए हम ट्रांसलेशन मैट्रिक्स प्रोवाइड कर देते हैं. ट्रांसलेशन मैट्रिक्स के अंदर ट्रांसलेशन फैक्टर्स मौजूद हैं, उनकी वैल्यूज हम अपनी मर्जी से, यूजर की मर्जी से स्पेसिफाई कर सकते हैं, और जो ही हमने वो स्पेसिफाई करके प्रोवाइड की, a command would help us make use of that transformation matrix to carry out that transformation. अगर ट्रांसलेशन की बात कर रहे हैं, the translation would be carried out. अगर हम रोटेशन की बात कर रहे हैं, स्केलिंग की बात कर रहे हैं, अकॉर्डिंगली हम रिस्पेक्टिव ट्रांसफॉर्मेशन मैट्रिक्स को सेट करते हैं और ये इंफॉर्मेशन प्रोवाइड कर देते हैं टू OpenGL, एंड अ कमांड इज इश्यूड टू एग्जीक्यूट द रिस्पेक्टिव ट्रांसफॉर्मेशन. Lighting equations, we have talked about lighting equations in different lighting models, and we have talked about different parameters that help us make use of those lighting equations. उन parameters की values को हम खुद से specify कर सकते हैं. We can choose a specific model to be used in our specific scene or animation, and then उनके ऊपर control हमें available है that we can provide the parameter values ourselves. So वो कोएफिशिएंट्स जो कि चेंज लाते हैं किसी भी तरह के लाइटिंग मॉडल के अंदर, उनको हम अपनी मर्जी से कंट्रोल कर सकते हैं. फिर एंटी एलियासिंग के हवाले से हम टेक्निक्स जो इस्तेमाल करनी है, जो मेथड्स यूज करने हैं, वो बता सकते हैं. एंटी एलियासिंग का हमने डिटेल से जिक्र नहीं किया था. बेसिक आइडिया जो एलियासिंग का है वो ये है कि जब कभी भी हम कोई किसी एंगल पर कोई लाइन ड्रॉ करते हैं तो डिपेंडिंग अपॉन द रेजोल्यूशन सपोर्टेड बाय आवर डिस्प्ले डिवाइस, लाइन जो है उसके ऊपर एक जैगेड सा इफेक्ट, स्टेयरकेस लाइक इफेक्ट जो है वो दिखाई देता है. स्टेयरकेस लाइक इफेक्ट स्ट्रेट लाइन में ये एविडेंटली विजिबल होगा अगर हम उसको एक मतलब स्ट्रेट लाइन इन हॉरिजॉन्टल और वर्टिकल डायरेक्शन ना बना रहे हों, एट सम अदर स्लोप उसको ड्रॉ करें तो विल बी एबल टू एविडेंटली स्पॉट दिस जैगेडनेस और स्टेयरकेस लाइक इफेक्ट. दिस इज ऑल्सो विजिबल फॉर अदर ऑब्जेक्ट्स. कर्व्स के अंदर भी आपको दिखाई दे जाता है. जहां कहीं सर्कल्स के ऊपर हमने बात की थी जब, तो उसके अंदर भी वी सॉ दिस इफेक्ट, इसको मिनिमाइज करने की बहुत सारी टेक्निक्स हैं जिनको एंटी एलियासिंग टेक्निक्स कहते हैं. वो एंटी एलियासिंग टेक्निक्स या मेथड्स वो इसके अंदर बिल्ट इन मौजूद हैं और उनमें से कोई भी एक हम जैसे हमारी रिक्वायरमेंट हो उसके मुताबिक चूज कर सकते हैं और इस्तेमाल कर सकते हैं. OpenGL commands specify how a certain result should be produced, the procedure to be followed. OpenGL is fundamentally procedural rather than descriptive. So, OpenGL के अंदर हम ये बताते हैं कि क्या प्रोसीजर है जिसको फॉलो करना है. ये नहीं बता सकते कि क्या अल्टीमेट रिजल्टेंट है जो हमें चाहिए. अल्टीमेट रिजल्टेंट जो हमें चाहिए उस तक पहुंचने के लिए रास्ता कौन सा इस्तेमाल करना है, कौन कौन से स्टेप्स हैं जो परफॉर्म करने हैं, वो हम बताते हैं. इस सेंस में ये कहा जाता है कि OpenGL इज प्रोसीजरल इन नेचर. इट इज नॉट डिस्क्रिप्टिव ऑफ व्हाट यू वांट एज द एंड रिजल्टेंट. यू स्पेसिफाई व्हाट टू डू, द प्रोसीजर you tell, that procedure is followed and ultimate resultant comes in front of you, and depending upon your requirements you can change that procedure to come up with a different resultant at the end. Now we come to the execution model in which we will be seeing how OpenGL works, what are the different phases through which our objects or object related data goes through. It's a client-server model. Application code issues commands, and these are processed by OpenGL. So, a typical client-server environment concept is applicable. The client side, our application, which requires the functionality built into OpenGL to be utilized or exploited, that issues OpenGL commands, and those commands get executed by the OpenGL. And the resultant is made use of by the application making use of those function calls. OpenGL is network transparent. A server can maintain several OpenGL contexts. A client can connect to any of the contexts. OpenGL is network transparent, so it really doesn't bother OpenGL whether it resides on a different machine and the client application is residing on a different machine, or whether it is residing on the same. Regardless of the mechanism used to make the client and server communicate, OpenGL works. So OpenGL is network transparent. इसकी कोई परवाह नहीं होती कि रिक्वायरमेंट ये है कि एक पीयर टू पीयर कनेक्शन ही होना चाहिए, या एक प्योर नेटवर्क सर्वर और वर्क स्टेशन का आपस में कनेक्शन ही मौजूद होना चाहिए, या एक ही मशीन के ऊपर दोनों चीज़ों को मौजूद होना चाहिए. It works independent of these. It is capable of performing the very way it performs if it is residing on the same machine that the client application is residing, or if it is residing on a different machine. And a server can maintain several OpenGL contexts. A client can connect to any of those contexts, which means that we can have multiple contexts of OpenGL open and available at the server side at the same time. जब भी कभी हम कोई एक टॉप लेवल की विंडो डिफाइन करेंगे तो हम देखेंगे कि उसके साथ एक कॉन्टेक्स्ट एसोसिएट हो जाता है, एंड दैट इज अवेलेबल फॉर यूज बाय द क्लाइंट. एंड वी कैन हैव मल्टीपल ऑफ सच कॉन्टेक्ट्स, एंड client can connect to any of those contexts at any time and can issue commands that would be executed for that very context only. Network protocol may be an already existing protocol or an independent protocol. You can have specific protocol made for it, or any of the existing protocols that are available for the network that can be made use of, and OpenGL can work smoothly on it. No OpenGL commands are provided for obtaining user input. So this is an important thing to note कि OpenGL के अंदर कोई सी भी कमांड्स ऐसी नहीं है जिनकी मदद से, जिनको यूज करते हुए आप यूजर की इंटरवेंशन जो है वो कोड कर सकें प्रोग्राम्स में. सो यूजर इनपुट लेने के लिए आपको खुद ही काम करना होगा. हैविंग एक्वायर्ड enough information and data from user, जैसी भी रिक्वायरमेंट हो हमारी एप्लीकेशन की, अगर उसके अंदर इंटरेक्शन ऑफ द यूजर इज बेसिक रिक्वायरमेंट, हम वो इंटरेक्शन जो है वो खुद से कोड करेंगे. अगर हम C में काम कर रहे हैं या C++ में, तो वो वाला काम हम उसमें करेंगे, एंड देन we'll make use of the OpenGL functions to carry out operations, maybe based on that very data that we have got from the user. We have another way out as well that we will be discussing shortly. The window system that allocates frame buffer resources ultimately controls the effects of OpenGL commands on the frame buffer. Window system जिसके अंदर actually वो frame buffer exist करेगा, which would be managing and controlling the overall picture. Of course उसके ऊपर dependency रहेगी, because when we are talking about a specific window which is created using the capabilities of a windowing system और उसके ऊपर हम operations कर रहे हैं, तो वो window जो है उसको control करने के लिए तो जो windowing system है उसी की अजारादारी है. The way windowing system feels like making use of or defining or describing or keeping the state of a specific window, that is native with the windowing system. We will have to honor all those aspects which are governed by the windowing system, but then again within that window we can make use of the OpenGL functions to draw and to manipulate our 2D and 3D graphics. But the frame buffer of course is going to be created in that very windowing system, so any information that ends up in the frame buffer would be governed by the basic rules defined by the windowing system. The window system determines the portions to be accessed at any given time and communicates to OpenGL how those portions are structured. Frame buffer मौजूद है, is being maintained by the windowing system, so windowing system has to provide information for OpenGL's consumption that what portions of that frame buffer can be accessed and how they can be accessed, and then how they are organized and how they can be made use of by OpenGL. Once OpenGL gets access to that part of the frame buffer, उसके बाद फिर it is up to the OpenGL how it makes use of it, what data to put in. We have been talking about making use of the frame buffer for making images for our display devices originally. It also provides information that how the frame buffer is structured. So it also provides this information of what is the structure of a specific portion of the frame buffer and how it can be made use of by OpenGL. No OpenGL commands to configure the frame buffer or initialize OpenGL are available. Configuration is done outside of OpenGL in conjunction with the window system. As I said earlier, कि कंट्रोल जो है फ्रेम बफर पर वो जो गवर्निंग विंडोइंग सिस्टम है उसी का है. कोई भी OpenGL की ऐसी कमांड अवेलेबल नहीं है जिसकी मदद से हम फ्रेम बफर को इनिशियलाइज कर सकें या अपनी मर्जी से कॉन्फ़िगर कर सकें. सो फ्रेम बफर की इनिशियलाइजेशन और कॉन्फ़िगरेशन का काम जो है वो हमें विंडोइंग सिस्टम के तहत रहते हुए ही करना पड़ेगा. उसके लिए भी वी हैव वेज अराउंड, एज आई सेड अर्लियर एज वेल, वी विल बी मेकिंग यूज ऑफ सर्टेन वेज अराउंड. The configuration of these frame buffers is done outside OpenGL. OpenGL has not got anything to do with configuring or initializing the frame buffer. Basic OpenGL operation. You are looking at an image, an illustration, which gives you an idea of the OpenGL visualization programming pipeline. Now in this pipeline, you can see there are certain portions. Clearly दो हिस्से आपको इसके दिखाई दे रहे हैं. एक तो टॉप वाली स्ट्रिप है और एक स्ट्रिप आपको बॉटम पे दिखाई देती है. टॉप स्ट्रिप के ऊपर आप गौर से देखिए तो यू विल बी सीइंग इमेजिंग पाथ रिटन एज अ टाइटल, और जो बॉटम स्ट्रिप है उसके ऊपर ज्योमेट्री पाथ लिखा हुआ है. इमेजिंग पाथ वो वाला पाथ है जो उस वक्त लिया जाता है फॉर प्रोसेसिंग ऑफ डेटा जबकि हमारा इनपुट डेटा जो है वो इमेज रिलेटेड है, यानी पिक्सल्स की फॉर्म में है. तो अगर हमारे पास पिक्सल्स की फॉर्म में डेटा अवेलेबल है और उसको हम प्रोसेस करने जा रहे हैं मेकिंग यूज ऑफ OpenGL, तो जिस पाइपलाइन से वो गुजरेगा वो हमें टॉप पे दिखाई दे रही है. जबकि बॉटम वाली जो पाइपलाइन है दैट इज यूज्ड फॉर द ज्योमेट्रिक डेटा. वर्टिसेस में अगर इंफॉर्मेशन अवेलेबल है तो उसको हम किस तरीके से प्रोसेस करेंगे वो आपको ये लोअर पार्ट दिखाई दे रहा है. द इमेजिंग पाथ, द टॉप वन, स्टार्ट्स एट द इमेज, और अगला जो स्टेप है उसका वो है अनपैक पिक्सल्स, और उसके बाद फिर हम पिक्सल रिलेटेड ऑपरेशंस कैरी आउट करते हैं. एंड हैविंग डन दैट, दो पॉसिबिलिटीज हैं उस पिक्सल डेटा के साथ। एक तो यह है कि उसको हम टेक्सचर मेमोरी में जाके लिख सकते हैं। टेक्सचर मेमोरी में जो कुछ पड़ा होगा दैट वुड बी मेड यूज ऑफ लेटर ऑन फॉर सम फाइनल फ्रेगमेंट ऑपरेशंस, और उसके बाद फिर वो फ्रेम बफर में जा सकेगा। या फिर इस डेटा को हम इमेज रास्टराइजेशन के स्टेप को फॉरवर्ड कर सकते हैं, जहां से फिर नेचुरली इसने जाना वही है कि फ्रेगमेंट ऑपरेशंस के स्टेप से गुजर के फ्रेम बफर में पहुंचना है। सो ये तो वो पाइपलाइन है जिसमें से इमेज स्पेसिफिक डेटा या पिक्सल्स की फॉर्म में जो डेटा है वो गुजरेगा। जो डेटा वर्टिसेस की फॉर्म में है दैट वुड बी टेकिंग द अदर रूट, जिसमें हम स्टार्ट करेंगे उसकी ज्योमेट्री से, विच वुड बी ऑफ कोर्स द वर्टिसेस एंड देयर रिलेटेड डेटा। सो वील अनपैक वर्टिसेस, नेक्स्ट स्टेप में वर्टेक्स रिलेटेड ऑपरेशंस कैरी आउट होंगे, एंड उससे अगले स्टेप में फिर ज्योमेट्रिक रास्टराइजेशन होगी। ज्योमेट्रिक रास्टराइजेशन की कंप्लीशन के बाद फिर फ्रेगमेंट ऑपरेशंस कैरी आउट होते हैं इक्वली दोनों पर, इमेज वाले पार्ट पर भी और जो ज्योमेट्रिक डेटा से रिलेटेड पार्ट है उस पर भी, एंड फाइनली वी गेट द इंफॉर्मेशन दैट कैन बी पुट इनटू द फ्रेम बफर फ्रॉम वेयर इट वुड बी यूज्ड फॉर क्रिएटिंग द अल्टीमेट इमेज। इस दौरान दो चीजें और भी यहाँ पे दिखाई दे रही हैं जिनको मैंने अभी मिस किया, डिस्प्ले लिस्ट और टेक्सचर मेमोरी। डिस्प्ले लिस्ट जो है ये वो एरिया है जिसको आप काइंड ऑफ अ बफर समझ सकते हैं। हम बात कर रहे थे जब कोई एक कॉन्टेक्स्ट में कोई स्पेसिफिक कमांड जो है वो एग्जीक्यूट हो रही है तो उस दौरान जो मजीद कमांड्स आती जाती हैं वो वेट करती हैं, सो वो इस डिस्प्ले लिस्ट के अंदर वेट कर सकती हैं। दे एक्चुअली आर बफर्ड ओवर हियर, एंड देन जब उनकी बारी आती है तब वो यहाँ से एग्जीक्यूट होना शुरू हो जाती हैं। सो डिपेंडिंग अपॉन वेदर अ कमांड इज रिलेटेड टू द इमेज और पिक्सल डेटा, इट वुड बी टेकिंग दैट टॉप वाला रूट, और अगर वो वर्टेक्स रिलेटेड या ज्योमेट्रिक डेटा है तो फिर वो बॉटम वाला रूट लेके चलेगी, एंड दैट्स द वे इट वुड बी इन जनरल प्रोसेस्ड। अब इन जो फेजेस हैं इनको हम थोड़ा सा क्लोजली भी देख सकते हैं। एज आई सेड, display list is one of those things that we have talked about, is there at times when we require, or there is a requirement because of the current processing state of a context, कुछ commands जो कि issue हो चुकी हैं लेकिन अभी execute नहीं हो रही, वो यहाँ पर wait कर सकती हैं, और अगर हम चाहें तो इस display list के अंदर खुद से भी commands को temporarily रोक सकते हैं so that हम after a while उनको इकट्ठा process कर सकें। The other part that we talk about is evaluator. Evaluator provides an efficient way to approximate curve and surface geometry by evaluating polynomial commands of input values. ये वो पार्ट है जिसके अंदर जितनी भी इनपुट वैल्यूज आ रही हैं उनको इस्तेमाल करते हुए जितनी पॉलिनोमियल कमांड्स हैं उनकी इवैल्यूएशन होती है, सो दैट वी हैव अप्रोक्सीमेटेड आवर कर्व्स और द ज्योमेट्री दैट वी वांट टू यूज फॉर सरफेस रेंडरिंग। Then we have some per vertex operations and primitive assembly. The OpenGL processes geometric primitives or points. Vertices are transformed and lit, and primitives are clipped to the viewport in preparation for rasterization. So this is that part in which, if required, some clipping would take place, and maybe we'll have some new vertices introduced as well. Then is the rasterization step. Mind you, this is the pipeline for the data which is defined using vertices, geometric data जो उसके हवाले से हम बात कर रहे हैं. The rasterization stage produces a series of frame buffer addresses and associated values using a two-dimensional description of a point, line segment or polygon. So the primitives that we are going to make, अब उनकी rasterization का वक्त आता है. इस stage के ऊपर frame buffer के लिए वो addresses जो हैं वो और उनके ऊपर जो values आनी हैं वो finalize हो जाती हैं जहां पर उस डेटा को लिखा जाना है. Each fragment so produced is fed into the last stage which is called per fragment operations. Per fragment operations are the final operations performed on the data before it is stored as pixels in the frame buffer, because ultimately जिस चीज ने डिस्प्ले होना है उसको फ्रेम बफर में पहुंचना होगा और वो एज पिक्सल वैल्यूज ही पहुंचेगी. So where a specific pixel value is going to be stored is decided, and then finally it is put there for use of the display hardware. Per fragment operations include conditional updates to the frame buffer based on incoming and previously stored z values. We can also depth का concept alter करने के लिए भी इस्तेमाल हो सकता है, और उसके अलावा we can make use of the idea of alpha. Can you recall the alpha? Alpha blending का काम यहाँ पर हो सकता है. द इनकमिंग वैल्यूज एंड द स्टोर्ड वैल्यूज, उनके बारे में डिसाइड हो सकता है कि उनमें से किस वैल्यू की कितनी कंट्रीब्यूशन होगी इन द फाइनल इमेज, और उसके अंदर पिक्सल वैल्यू अल्टीमेटली क्या बनेगी. जो पहले से फ्रेम बफर में मौजूद हैं और जो अभी कैलकुलेट होके आई हैं वैल्यूज, उन दोनों को ब्लेंड करके हम अल्टीमेट रिजल्टेंट जो भी हासिल कर सकते हैं. Data can be input in the form of pixels rather than vertices, and whenever we have pixel data coming in, we will be talking about the other part of the pipeline. Following the pixel operations, the pixel data is either stored as texture memory for use in the rasterization stage, or the resulting fragments merged into the frame buffer just as if they were generated from the geometric data. So, depending upon what type of data is coming in, the type of processing would be altered, but ultimately they have to be through the last step of rasterization and then into fragmentation. So, today we have talked a bit about OpenGL. We have tried to introduce ourselves to this graphics library. इसकी capabilities बहुत ज़्यादा हैं, इसके अंदर functions बेतहाशा हैं. We will require a lot of time to be dedicated if we want to master it. But definitely, this is a very, very interesting journey that we have set out on. And I hope each one of you would be able to uniquely enjoy this journey. Because when you are developing things, your imagination can take you anywhere. And when it comes to computer graphics and making use of OpenGL for that, definitely it is going to help you a lot. And you will be able to create really fascinating images making use of the available API. With some more of the examples and samples as well. I hope to see you again next time inshallah. तब तक के लिए इजाज़त दीजिएगा. फ़ी अमान अल्लाह.